Yeah, there. Welcome back to the channel. Let's just get right into it. In the previous chapter, we completed till 13.6. In this, we'll be trying to complete 13.7, 13.8, and 13.9. Maybe we will go beyond and complete 13.10, but we never know. But this is our target 7, 8, and 9. So that is it. Let's just get right into it. So we need more. Uh, okay. There are many instances in programming where we need more than one variable in order to represent something of interest. Wait, I'm audible. Audible recording, audible recording, audible recording. Cool. A fraction has a numerator and denominator that are linked together into a single mathematical object. Alternatively, let's say we want to write a program where we need to store. Yeah, okay. So I've read this part. Yeah, defining structs. This is cool. Employee ID, Joe, Joe Mama. Create employee struct for Frank. This defines a variable of type employee named Joe. When the code is executed, an employee object instantiation that contains three data members. Uh, Three data members. The empty braces ensure our object is value initialized. Cool. ID, age, and wage. Accessing members. Consider the following example. Struct this into main. Cool. In the above example, the name Joe refers to the single struct object which contains the member variables. To access a specific member variable, we use the member selection operator, uh, whatever, operator. Cool. We use the selection operator, which is operator dot. Is this the selection operator? Between the struct variables. In between the struct variables. What are we talking about? Uh, for example, to access a Joe's name. Oh yeah, yeah, yeah. Got it. Struct member variables work just like normal variables, so it is possible to do normal operations on them, including assignment, arithmetic, comparison, etc. Struct employee ID, age, wage. This age equal to 32. Dot to select the age member of the variable Joe, and Joe dot age. This prints 32. One of the biggest advantages of structs is that we only need to create one new name for struct variable. One of the biggest advantages of the struct is that we only need to create one new name per struct variable. The member names are fixed as part of the struct type definition. In the following example, we instantiate two employee objects, Joe and Frank. So Joe is this, Frank is this, total age. Joe and Frank have lived total years. And then if Joe's wage, Joe makes more than Frank. If smaller, it equal Frank age wage is increased and Joe's age is increased. In the above example, it is very easy to tell which member variables belong to Joe and which belong to Frank. This provides a much higher level of organization and individual variables would than individual variables would. Furthermore, because Joe's and Frank's members have the same names, this provides consistency where you have multiple variables of the same struct type. We'll continue our exploration of structs in the next lesson, including a look at how to initialize them. Yep, cool. So struct aggregate initialization, and how big is this chapter? Yeah, okay, I don't think it's that big because I can see most of it is just code. So in the previous lesson, 13.7, Introduction to Structs, Members and Member Selection, we talked about how to define structs, instantiate struct objects and access their members. In this lesson, we'll discuss how structs are initialized. Data members are not initialized by default. Much like normal variables, data members are not initialized by default. Consider the following struct. Okay. Yeah, they are not initialized. No initializer here. Age, wage, code, cool. Because we have not provided an initializer, when Joe is instantiated, they all will be uninitialized. Or maybe if we do the direct list initialization with nothing between it will be zero. Behavior or null or whatever. Behavior when we try to print the value of Joe or ID. However, before we show you how to initialize a struct, let's take a short detour. What is an aggregate? In general programming, an aggregate data type, also called an aggregate, is any type that can contain multiple data members. Some types of aggregate allows members to have different types, example structs, while others require all members must be same, like an array. Single type example arrays. Yep. In C++, the definition of an aggregate is narrower and quite a bit more complicated. Okay. On this note, in this tutorial series, when we use the term aggregate or non-aggregate, we will mean C++ definition of aggregate. Okay. For advanced readers, to simplify a bit, an aggregate in C++ is either a C-style array, this, or a class type, struct, class, or AL. Okay. No user declare constructors, no private or protected non-static data members, no virtual functions. The popular type stood array is also an aggregate. You can find the definition of C++ aggregate here. The key thing to understand at this point is that structs with only data members are aggregates. That structs with only data members are aggregates. Aggregate initialization of a struct. Because a normal variable can only hold a single value, we only need to provide a single initializer. Int x, phi. However, a struct can have multiple members. This, when we define an object with a struct type, we need some way to initialize multiple members at initialization time. How do we initialize Joe or ID? This aggregate uses a form of initialization called direct aggregate initialization, which allows us to directly initialize the members of the aggregates. To do this, we provide an initializer list as an initializer. Yep, okay, which is just a braced list of comma separated values. There are two primary forms of aggregate initialization. Okay, so copy list initialization using braced list. Okay, and then this is direct list initialization. List initialization using braced list. This is preferred. Okay. Each of these initialization forms does a member-wise initialization, which means each member in the struct is initialized in the order of declaration, ID, age, and wage. Thus, employee Joe to retrieve this first initialize Joe ID with 2, Joe age with 28, and wage with 45,000. Yep. Best practice prefer the non-copy braced initialization non-copy braced list form when initializing aggregates. In C++20, we can also initialize some aggregate using parenthesized list of values. Okay, direct initialization using parenthesized list. So this is list initialization. So this is in C++20. We recommend avoiding this last form as much as possible as it doesn't currently work with aggregate that utilize brace Ellison, notably stood array. Okay, missing initializers in an initializer list. If an aggregate is initialized but the member of initialization values is fewer than the number of members, then each member without an explicit initialization. Okay. If an aggregate is initialized but the number of initialization values is fewer than the number of members, then each member without an explicit initializer is initialized as follows. If a member has a default member initializer that is used, otherwise it is zero, right? The member is copy initialized from an empty initializer list. In most cases, this will perform value initialization on those members on class type that will invoke the default constructor even after this constructor exists. So they mean that if 228 was found, then what they will do is that 2 will go here, 28 will go here. Since there was no initialization for the wage one, see there's nothing over here. It will be initialized with the first, like the first check. If the member has default member initializer, which is we do have 76,000. Otherwise, the member is copy initialized from an empty initializer list, will be initialized from an empty initializer list. In most cases, this will perform value initialization on those members on class type that will invoke the default constructor, even if it is a list constructor exists. Wait, I don't understand this state. Just give Back again. So I have this doubt. So let's color. I understand. In C++, when you initialize an aggregate like a struct, you provide fewer values than the number of members. The remaining members will be initialized. Default is if a member has default initialization, example this, the default value is used. Empty initializer list. If no default member initialize exists, the member is copy initialized from an empty initializer, which is effectively means the member gets initialized using value initialization. For primitive types like this, it is initialized to zero or null. For class types, it calls the default constructor even if there's a constructor that takes an argument. Even if there's no initializer provided. What happens when the what happens when the takes in a object type? Will the object be will the object be I don't get it, but okay, I'm going to move forward. So struct employees this we know understand. In the above example, Jura ID will be initialized with true because this will be this, and finally Jura whatever wasn't given an explicit initializer is initialized to 0.0. This means we can generally use an empty initialization list to value initialize all members of the struct. Value initialize all members. What is the meaning of value initialize? Means initializing an object to a default empty state. For built-in types, this is value initialization. Okay, cool. So I've been using value initialization for like quite time, and I used to think that it is called direct list initialization, but okay, I get it now. It's called value initialization. In 13.5, introduction to overloading I/O operators. Uh, Overloading the I/O operators, we showed how to overload this. Yup, and I remember that to print an enumeration, it's also useful to overload this for structs. Here's the same example as in the previous section, now with an overloaded operator. Okay, this hmm, OS stream operator this, so the OS stream goes this, and then we return the OS stream again. Cool. This prints this. We can see that Joe.page was initialized to 0, which prints at 0. Unlike any enumeration, a struct can hold multiple values. How you format the output. Example to separate the values, it to separate the values is entirely up to you. The three values output by your overload this above aren't intuitive as there is no indication of what type of values mean. Let's do the same but update our output function to be a bit more descriptive. Yep, I read this. Yep, cool. Constructs, variables of struct types can be const or const expr, and just like all const variables, they must be initialized. Okay, cool. This can be const, designated initializers, value initialize all members, designated initializers, C++20. When initializing a struct from a list of values, the initializers are applied to the member in our order of declaration. When initializing a struct from a list of values, the initializers are applied to the members in order of declaration. Hmm. So foo f1 3. So A gets 1 and C gets 3. Now consider what would happen if you were to update this struct definition to add a new member that is not the last member. B was just added, but B will get the 3 instead of C. Now all your initialization values have shifted, and worse, the compiler may not detect this as an error. After all, the syntax is still valid. To help avoid this, C++20 adds a new way to initialize struct members called designated initializers. Designated initializers allow you to explicitly define which initialization values map to which members. Yep, I remember that. The members can be initialized using list or copy initialization. The members can be initialized using list or copy initialization and must be initialized in the same order in which they are declared in the struct. Okay, the members can be initialized using list or copy initialization and must be initialized in the same order in which they are declared in the struct. Otherwise, a warning or error will result. Members not designated initializer will be value initialized. Mhm. Back again. So 18 minutes in, and we are doing great, let's complete this. To help avoid this, we use this syntax map to which members. The members can be initialized using list or copy initialization, must be initialized in the same order in which they are declared in the struct, otherwise the routing will error. Members are not decided. This for Clang users. Oh, okay, for Clang users. I'm a Clang user because I'm on Mac and I guess there is no problem with Clang. Clang is cool. I'm accustomed to writing the Clang. Sorry, Clang plus plus stored equal to C plus plus 17 mean dot cpp and then dot a dot out. I'm accustomed to that, so I don't have any problem with that. Uh, it become small, become big, cool. Okay, so this is direct initialization or sorry, this is value initialization, my bad. So value initialization, this is also the same thing, I guess. So this is a copy initialization, right? Right? Okay, the order is bad. The order should not be like this. So A, this, B, A. So A, C is fine if it's fine if we skip the B, but this is not cool. Sorry, this is not cool. Okay. For Clang users, when doing designated initializers of single values using braces, Clang improperly issues warning uh, braces around scalar initializer. I'm so sorry. I'm so sorry. When doing designated initializer of single values using braces, Clang improperly issues warning braces around scalar initialization. Hopefully, this will be fixed soon. So, what error are they talking about? Because I need to understand stuff, you know. What do they mean here? Also, I want to recreate it. Give me sample code. Till then, we'll just copy the normal code and check if Clang gives any error. Okay, so desktop, yeah, that's nothing. You know, I should stop clearing the screen every single time, you know. That is, like, I don't necessarily think that it's a bad habit, but the history gets messed up, you know. Yeah, okay, there is an error. Something related to scalar. And what does that mean? Basis around scalar initializer. And why is there error? Demonstrate designated initializers in C++ which were introduced in C++ 20. Oh, okay. So if I do C++ 20, then it's fine, right? No. If I do 23, that is still not fine. Initializer syntax. The this syntax is used to directly this. Cool, cool, cool. What's allowed in the line? This is fine because A, C are initialized and B gets its default value, that is this. Similarly, this is also works fine. What's not allowed is this. Cool. Clang warning. When using brace initialization for scalars like int, Clang issues a warning braces are not scalar initialization, which is a minor issue where it doesn't like braces around scalar values. This might get fixed, but why? So it doesn't like this, right? So how about we do this and do this? How about now? Yep, works fine. Cool. What to do if you want to fix the error? This. To fix the error, the initialization order should respect the order of the member declaration in the struct. For example, you could write this. Okay, so let's try this. So this should give me an error. Yup. And when I go over here and I do this, this should work, which it doesn't. And if I try this dot C4, what do I get? Still the error, which is cool. F1 dot A, F1 dot B, F1 dot C, student L. Oh, there's no IO string. Okay. Yep, cool. The issue you're seeing in Clang regarding the warning basis on scalar initialization, White believes definitely from GCC comes down to how each compiler handles certain language features. The warning this when you use brace initialization for a scalar type like int, it's allowed by C++ standard, but Clang issues a warning about it. What? No, it doesn't. Okay, I just don't want to talk to this clanker. Designated initializers are nice because they provide some level of self-documentation and help ensure you don't inevitably mix up the order of your initialization of values. However, designated initializers also clutter up the initializer list significantly. Yes, as I can see, this is so we won't recommend to use this as the best practice. Also because there's no enforcement that designated initializers are being used consistently everywhere as an aggregate is initialized. It's a good idea to avoid adding new members in the middle of an existing aggregate definition to avoid the risk of initialization. Best practice, when adding a new member to an aggregate, it's safest to add it to the bottom of the definition list so the initializer for other members don't shift. Assignment with an initializer list. As shown in the prior lesson, we can assign values to members of structs individually. Struct this, we can assign this, yep, cool. Joe had a birthday and got a raise. Cool. This is fine for single members, but not great with multiple ones. When we want to update many members, similarly to initialize a struct with an initializer list, you can also assign values to struct using an initializer list, which does member-wise assignment. Okay, Jura ID. So this stays the same. So it's still one. Okay, cool. Well, because we didn't change this in our list as a placeholder, so that the member-wise assignment could assign Jura ID to Jura ID. This is a bit ugly. Assignment with designated initializers. C++ 20. This ID age wage. This ID equal to Jura ID. This. Joined birthday got a raise. Any members that aren't designated in such a assignment will be assigned the value that would be used for value initialization. If we hadn't have specified a designated initializer for Joder ID would have been assigned to the value 0. Okay. Initializing a struct with another struct of the same type. Okay, so a struct may also be initialized using another struct of the same type. So struct foo, OS stream, okay, this just prints out stuff. Foo was given A is equal to 1, B is equal to 2, C is equal to 3, copy initialization, direct initialization, and direct list initialization. This, X, Y, and Z. So we are about to see 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes. Note that this uses the standard forms of initialization that we are familiar with, copy direct or direct list, rather than aggregate initialization. This is most commonly seen when initializing a struct with the return values of a function that returns a struct of the same type. We cover this in the more detail in lesson 13.10, passing and returning structs. Cool. So this is, I guess this is the last chapter that we are supposed to read, and it's quite small. Yeah, let's go. Cool. So default member initialization. When we define a struct or class type, we can provide a default initialization value for each member as part of the type definition. For members not marked as static, this process is sometimes called non-static member initialization. The initialization value is called a default member initializer. Related content. Okay, I did not understand that because I was zoned out. I'm so sorry. This is 30 minutes. This is going to be a 45 minutes video, and we are covering three sub chapters. I guess the sub chapters are small. Also, if you're watching this video, this is 30-minute mark. Most of people don't watch this video like this far. And if you're watching this, stop. You know, you're not going to get any kind of value unless and until you like hearing me read stuff and blabbing about stuff. In that case, it's different. But usually, there's no use in watching me like read stuff and hearing me. So go ahead, work on something that you like. Go and talk with your mom or dad, or anyone that you like. And I guess that is it. Work on your stuff. This is just waste of time. YouTube, actually, YouTube is a waste of time. I don't watch YouTube. Just to show you, so these are the all the Google apps that I have so far. So I call them data chore. And if you don't understand what chore means uh, this is a very simple word. Chore means the guy that steals. What's it called? A robber, yeah. A robber, but not like robber is kind of like a big thing, right? Chore is kind of like, okay, I don't get it. Fine, call it robber. So I call it data robbers. The only apps left from data robbers, which is Google, is Gmail, Drive, and Play Store. To upload this video, I will download YouTube Studio temporarily, and then I will delete it again, remove its permission, cache, and any single thing. But I guess these are the only three apps that I'm left with. I don't think I can delete Play Store. I can't delete Play Store because it is, I think it is ingrained in a lot of stuff. Also, uh, like there are some apps, some government apps, some bank account apps, they do not open source that stuff, and like they are hell bent that they won't be open sourcing stuff because I guess it's good on their side because if you open source that kind of stuff, it's delicate. People might find bugs and try to find loopholes and try to hack into people's accounts and stuff. So I guess that is okay. But apart from that, I have some other government apps. I don't think I can delete them. I have de-googled my phone a lot. If you want to take a look at this. Most of the apps like calendar, audio recorder, files. Okay, I should show over here. Okay. Oh, I'm so sorry. I did not realize that I was on mute. I'm so sorry. But what I was saying that look how I've replaced every single stuff with open source apps. This is the app local send focus. Local send. Bro, this is the best app for transferring files locally between your devices, and it works on many different platforms. I highly recommend the app. Like, you guys are genius if you have made this. Okay, how about this? But where should I include it? I'm going to include the link for local send. Like I really like those guys. I'll include them in the pinned comment maybe. Pinned comment or description. My descriptions are usually empty. I'll look into it, but I'll tag them. And then most of the apps are Falsify apps. I haven't replaced, as you can see, the Google Clock because it's just smooth and it's not doing anything bad. I checked its permission. It's a bit bloat, but it's really smooth. And the timer thing that I like, I don't think I want to replace it. I haven't found any great alternative for it, but I'm looking for it. I'm open to your opinion. I guess that is it. I don't have Chrome. I don't have any bloat. I don't have YouTube. So that's what my main point was. That's what my main point was, which is I don't have YouTube, which means I don't waste as much time on YouTube, but I do waste a lot of time on Reddit. I don't have Reddit on my phone, but I use Reddit on my desktop. So I don't know what kind of point I was making there. I do waste some time, but not on YouTube maybe. YouTube is kind of like you sit there passively watching other person do something, but Reddit is more like like I don't watch memes on Reddit definitely. It's mostly like it's mostly reading, so at least I am engaging in the content. You can say kind of I don't think I should be justifying my uh, distractions, but I guess fine. I'm taking small steps one at a time, and soon I will not use Reddit at all. Let's get back into the video. Uh, when we define a struct or class type, we can provide a default initialization value for each member as a part of the type definition. For members not marked as static, this process is sometimes called non-static member initialization, which we can provide a default initialization value for each member as part of the type definition. For members not marked as static, this process is sometimes called non-static member initialization. The initialization value is called default member initializer. We cover this in 15.6. Okay, here's an example. So this explicit default value, when initialized, no initialization bad. This, this. Okay. In the above definition, something X has no default value, Y is value initialized by default, and Z has default value 2. Will be used if the user doesn't provide an explicit initialization value when initializing an object of type something. Our S1 object doesn't have an initializer, so members of S1 are initialized to the default values. Okay, so it remains uninitialized. S1.y is value initialized by default, 0, and this will be 2. Note that even though we haven't provided an explicit initializer for S1.z, it is initialized to a non-zero value because of the default member initializer provided. Cool. Key insight. Oh, I'm doing like imagine not taking the first word, not taking the first character and the last character of whatever stuff that I'm highlighting. So using default member initializers or other mechanisms that we'll cover later, using default member initializers or other mechanisms that we'll cover later, structs and classes can self-initialize even when no explicit initializers are provided. Can self-initialize even when no explicit. Okay. For advanced readers, CTED, this cannot be used in non-static. I shouldn't worry about that stuff. Explicit initialization values take precedence over default values. Yep, definitely it should. 567 will overwrite whatever stuff that this struct has going on over here. In the above case, S2 has, yep. In the above case, S2 has this, are not at all. This means this are initialized by 567. Missing initializers in an initializer list when default values exist. In the previous lesson, we noted that if an aggregate is initialized but the number of initialization values is fewer than the number of members, then all remaining members will be value initialized. However, if a given number, that means the formula will be used instead. However, if a default member initializer is provided for a given number, then this okay. Uh, Nothing is given. 0, 0, 0. Oh yeah. Wait a minute. So we are. This is not uninitialized. We are saying that we want it, but it is value initialized. So will they go all zero or will they go 0, 0, and 2? Not zero, but whatever the garbage value that they have going over here. No, I guess there won't be any garbage value over here. This. How about we print? Okay. In the case S3 is list initialized with an empty list, so initialization missing. This means that the default member initialization will be used if it exists. Oh yeah. So it's technically missing. So yep, which has nodes is value initialized to zero. This is also zero, and this is also zero. Recapping the initializer possibilities. If an aggregate is defined with an initializer list, if an aggregate is defined with an initialization list, if an explicit initialization value exists, that explicit is used. If it is missing and the default member exists, the default is used, is missing, and default is also absent, value initialization. With no initialization, default member exists, default is used, default member does not exist, the member remains uninitialized. Yep, got it. So it is if it is defined with if the initialization is missing, value initialization occurs. If the initializer is missing, with the initialization list. So even though just okay. So let me get this straight. So here we are using this. So okay. I'm going to do something. I'm going to try something. Okay, so this is struct something, and this is called struct something. How about that? Cool naming. And let's call this something S4. Cool name. Okay, so as you can see, this is S4. This is not value initialized. This is not list initialized. There is nothing over here. So when I do this, s3 cout, let's say s3 dot x, s3 dot y, and s3 dot z, and I do this, and I find 3, replace with 4, find 3, replace with 4, find 3, replace with 4. Let's check it out. Let's go. Since there was list initialization, 0, 0, and 2, we can see. And the first one, this is a garbage. This is garbage. If I do this again, there will be a different number. Check it out. It's same because RM the 8 all out, and now it should be different. Okay, I'm a dumb person. But that's fine, I understand stuff. The following example recaps all possibilities. So, yep, this. The case we want to watch out for is S1X. Yup, because S1 there is no, it will have garbage values. Has no initializer list and X has no default member initializer. S1.x remains uninitialized, which is bad since we should always initialize our variables. Always provide default values for new members. To avoid the possibility of uninitialized members, simply ensure that each member has a default value, either an explicit type, either an explicit default value or an empty pair of braces. That way, our member will be initialized with some value regardless of whether we provide an initializer list or not. Consider the following struct which has all members defaulted, numerator and denominator. Numerator can be whatever. Okay, cool. Fraction F1. Nothing. So 0 and 1 answer will be 1. Okay, I have to just say what is the numerator and denominator. So this default is so it's again 0 and 1. Yep. This is 6. So 6 and 1. Yep. And 5 and 8. So this is 5 and 8. Cool. In all cases, our members are initialized with values. Provide a default value for all members. This ensures that your members will be initialized even if the variable definition doesn't include an initializer list. Yep, cool. We are there. Default initialization versus value initialization for aggregates. Revisiting two lines from the above examples, this and this, you will know that F1 is default initialized and F2 is value initialized, yet the results are the same. Because this is list initialization, which would have happened if we include this or not. Okay, and since one, because default is present, either it was empty or you could use something default and default stays the same. I understand that stuff. The value initialization always prefer this way. Always. The value initialization case F2 is safer because it will ensure any members with no default values are value initialized. And although we should always provide default values for members, this protects against the cases where one is missed. Preferring value initialization has one more benefit. It's consistent with how we initialize objects of other types. Consistency helps prevent errors. Best practice for aggregates, prefer value initialization with an empty brace initializer to default initialization with no braces. That said, it's not uncommon for programmers to use default initialization instead of value initialization for class type. Okay, this is partly for historic reasons, as value initialization wasn't introduced until C++11, and partly because there is a particular case for non-aggregates where default initialization can be more effective than value initialization. Okay, default initialization can be more effective than we cover this in 14.11. Okay, okay. Therefore, we won't be militant about enforcing use of value initialization for structs and classes in these tutorials, but we do strongly recommend it. Okay, cool. So we have completed 13.9. In the next, we'll be going for 13.10. So 13.10, oops, sorry. So 13.10, 11, 12, and then 13, 14, 15, and then whatever. Let's check out 13.10, how big it is. Small, small, small. Bro, these are small chapters. Bro. So these are small chapters. Oh, sorry, my bad. We have completed this, passing and returning structs. This is this. We'll complete these in the next video. But okay, the next video will most likely be tomorrow, day after tomorrow. Yep, day after tomorrow. If this video, whenever this video gets uploaded, yeah, okay. I'm just not gonna say it because my things can change. But okay, thanks for watching this video. I am Aditya Pachane and I am engineer for fun. Bye.